So on the x-axis there are units of labor, and on the y-axis there are units of capital. And we can draw a line, we can call it line A, and line A will show the different levels of output that can be produced using different combinations of capital and labor. This is important as firms need to find the least cost or most efficient combination of the two. For many firms, labor is crucial and the greatest single expense. Similar to line A, we can draw a line B, and we can see that line B uses more capital than line A. It uses more capital than labor in general. Similarly, a line C, which is less steep than A, will use more labor than capital. Number of units produced on point X, 100. Number of units produced on point Y, 100. Number of units produced on point Z, 100. And then this line is the isoquant, which is the curve that shows the combinations of labor and capital that produce the same level of output. Isoquants can also be used to show the law of diminishing returns. So this is isoquant for 100 units. As we make isoquants for higher levels of production, the distance between them will keep getting smaller. So this is increasing returns to scale because relatively less capital and labor is required per unit of output. But then as we go further to higher levels of output, the distance will start to increase. The difference between the long run and the short run is not the amount of time that passes. In the short run, at least one factor of production is fixed, which is capital, because it takes time to arrange money to buy more capital. Labor is the factor that is easiest to change. In the long run, all factors of production are variable. Therefore, like we use the equimarginal principle to determine what quantities of multiple goods a consumer would consume, firms can also decide the quantities of various factors of production they should employ using a formula, which is marginal product of factor A upon the price is equal to the marginal product of the other factors divided by their price. It is not just this formula that is similar to the utility concepts that we have learned before. In indifference curve analysis, we pair the indifference curves that show the combinations of two goods that give the same level of utility with budget lines that show the actual amount we can buy within a limited budget. Over here, we pair isoquants that show the combinations of capital and labor that give the same level of output with isocosts that show the combinations of capital and labor that you can employ at one particular cost. The point where the isocost is tangential to the isoquant is the most efficient, least cost process. As can be seen in the graph, in the long run, the isocosts will shift to the right as more capital and labor can be employed. Joining the tangential points will give the long run production function. However, it can be difficult to determine the different combinations of capital and labor that give the same level of output, and therefore the isoquant, as the firm may not have the data or the staff know-how to be able to do this. Furthermore, it may not be easy for a firm to shift from one isocost to another.